So today we're going to start adding and subtracting these rational expressions. Just like when you're adding and subtracting fractions, this is when you have to get the common denominators. So we're going to look at ones that only have like denominators today, and then the next time we do notes, we'll look at ones where we have to get those common denominators first, okay? Everybody know where we're at in the notes? We good? Okay. Example 1. So this is all adding and subtracting. Remember from your order of operations days that adding and subtracting just happens from left to right. So we're going to do 8 minus 5 plus 9. And that'll all stay over that common denominator of 3b. So what is 8 minus 5?
3.
What's 3 plus 9?
12.
So I have 12 over 3b. Can I do anything with that? You can simplify it. So that'd be like 1 and a 4. So 4 over b is my answer. This is, I think the top of the notes say 6.4. So it says 6.5 on the top. Adding with like denominators. All right, questions? Here's example 2. All right, so do you see how the denominators are already the same? Okay, so I am going to write out the numerator. I am going to remember that I am subtracting each of those terms. You might want to put that in parentheses to help you remember that you're subtracting the 5x, you're subtracting the 4. So first I'm going to write it as one big rational expression. All over 8. Don't forget, minus 5x minus 4. Now combine your like terms. 6x minus 5x is 1x. Negative 1 minus 4 is minus 5 all over 8. The biggest mistake I see here, and a lot of you did this on your quiz when we had a similar type of a problem, you would only subtract the 5x and not the 4. So be very careful on that. You're subtracting that whole second expression. What are your questions? All right, here's example 3. All right, do we have common denominators?
No.
We don't. So what can I do? Yeah, let's just take a negative 1 out from here. You know what I'm saying? So if we make that negative, and then it'd be negative 3 plus r over 9 plus, right? Now, you guys know that when you have a negative like that, you can put it in the top or the bottom of the fraction, right? So I'm just going to stick it up here with my next step. So I'm going to make this r minus 1. I'm putting the negative up top with the 9. So that's r minus 1 minus 9 all over. Now the denominators are the same once you put that negative up top with the 9, right? Okay, so I'm going to write it as r minus 3. What is r minus 1 minus 9? R minus 10 over r minus 3. That one was kind of tricky. Any questions? Does it make sense to factor out the negative and then just put it up top? Okay. Here's number 4. All right, do I have common denominators? Yep, so I can go ahead and combine these. So my first numerator minus my second numerator all over the common denominator. Yeah, now that's a difference of squares. So I can write it as x plus y, x minus y, all over x minus y. What now? Get rid of them. X plus y is the answer. Questions? Okay. All right. Do I have common denominators? Yeah. All right, so we can go ahead and just add the numerators all over that common denominator. Oops, I dropped an X. Sorry. Okay, what's going to happen up top? We have x squared plus x squared. That's 2x squared minus, what's negative? X minus 2x. Negative 3x all over 6x squared minus x. All right, what next?
X squared and 6x squared.
Can you
simplify?
do the 2x squared plus the 6x squared?
So you simplify, so 2x would become, since they're both, they're all common, they all like they're common factors, so 2x squared is common, 6x squared, so will that be
Can I simplify terms like that? No, you can only simplify factors. So the only thing we can really do is try to factor. Can we factor anything out of everything in the top?
X.
So I could write this as x and then 2x minus 3. And then what about the bottom? X and then 6x minus 1. That's how you can get the x's to simplify. As far as like the 2 and the 6, that's not going to work unless every term in the top has a 2 and every term in the bottom has a 6, and you factor it out to the front, and then you make it 1/3. Right now we just have 2x minus 3 over 6x minus 1. That's as simple as we get. Questions? All right, here's number 6. All right, do I have a common denominator? Yes, and I am subtracting. So make sure when you write the next step, you're subtracting each of those terms in the second rational expression. This is 4 minus b plus 1. Everybody see that? Over b minus 5. So up top I have negative b plus 5 over b minus 5. So the b's have opposite signs. The 5 has opposite signs.
Same thing.
Yeah, if I take out a -1, up top, the negative b becomes a positive b, and the plus 5 becomes a minus 5. So what's my final answer going to be? Just -1. Good. Questions? All right, do I have common denominators? All right, so I can go ahead and combine the numerators. 8n plus 3, then what? Minus 2n plus 5. You got to take each term and change the sign, okay? Because we're subtracting that entire expression. All over 3n plus 4.
We get 6n plus 8.
6n plus 8 over 3n plus 4. Then what?
We simplify.
How did you get a 2? Where'd the 2 come from?
Take out a 2 from the top.
So you can divide each of them by 2 and write a 2 in the front because it's the GCF? Alright, so that would leave me with 3n plus 4. All over 3n plus 4.
2.
Which is 2. Why'd you say the right answer and then say that it wasn't the right answer?
Once you get 2, I divided the top by the bottom and got 2.
Oh, you just divided one of the terms? No, you got to factor first. I mean, you had the right answer, but yeah, your method of getting there might be one that trips you up in the future. So just factor before you cancel. Any questions? Whoa. Bless you. All right, so do we have common denominators? We have 3 fractions. They all have common denominators, right? So I'm just going to work left to right. I'm going to write it as one big rational expression, then I'm going to combine like terms if I can. Careful because the middle one is being subtracted. So it's like 7a minus 5a plus 4b or minus 4b? Minus 4b plus 2b or minus 2b? Plus 2b. Good. All over a squared minus b squared. So up top, what do we have? 2a minus 2b. It's -4 plus 2.
We have different.
All over here. I'm just going to write it like this first. But then, yes, we can factor both of these. What can you do up top?
Take a 2 out.
Take a 2 out. So you get a minus b. What do you do on the bottom? So a plus b, a minus b. All right, so 2 in the top and then a plus b. Questions? What? Somebody say something? Do your notes have directions?
No.
I'm assuming since we're...
Oh, find the perimeter.
Oh, okay. I was like, I'm assuming we're finding the perimeter. But mine doesn't have directions, which is interesting. But in the section about adding and subtracting, I would assume we're finding the perimeter. So yes, one way to think of finding the perimeter is adding all the sides. But we actually know a formula. What is it?
Length times width.
2L plus 2W. So I'm going to do 2 times n minus 1 over 5 plus 2 times n plus 4 over 5. Do I multiply or do I add first? Multiply. Good. So this is going to be 2m minus 2 over 5 plus 2m plus 8 over 5. Do I have common denominators? Yes, I do. So I can go ahead and write these together. 2m minus 2 plus 2m plus 8, which final answer is 4m plus 6 all over 5. Now, as you get better at this, like maybe this step isn't going to be crucial for you to write out. Did some of you feel like you wanted to go straight from here to here? That's fine. Once you start seeing where these are coming from, you're good. Questions? All right, what did we learn about today? Hold on one second. Hold on, sorry, we did have a question on the last one. What was the question?
Why don't the 5s multiply into 10s?
Okay. Back it up. So if we were multiplying so you mean back at this step?
Yeah.
Because when you're multiplying by 2, we wanted 2 times the length and 2 times the width. So that would be like 2 over 1. So you'd be multiplying the denominator by the 1. I think you're getting it confused with when you're finding common denominators and you multiply by the same number on top of itself. Like 2 over 2 if we wanted to make the denominator at 10. But yeah, when we're multiplying by 2, it's like 2 over 1. So you only multiply the numerator. All right, back to this. What did we learn about today? Adding and subtracting with like denominators. Good. Great. Do you guys have any last minute questions before I pass out the homework?